In this video, we'll look at using double angle formulae. In particular, the question asks us to solve for sine of 2 theta, cos of 2 theta, and tan of 2 theta if we know that cos of theta is negative 4 over 5 and theta is between pi over 2 and pi. So that's going to put us in quadrant 2. Let's draw a sketch, x and y axis, initial arm, gotta label these things, and terminal arm in quadrant 2, that's up here. Label this as theta. What we really want to know are what's sine and what's tan, because we already have cosine. We're going to use these formulae, you'll see. So we're looking for this triangle here, and we know cosine of theta is adjacent, so that's negative 4, over hypotenuse, so that's 5. So to find that missing side, let's call this missing side y, we need to figure it out using Pythagorean theorem. We have a right angle triangle, so a squared plus b squared equals c squared. We can solve for this y squared using negative 4 squared equals 5 squared. So you can use a calculator, or negative 4 squared is 16, 5 squared is 25. How do you get y squared by itself? Subtract 16 both sides, and you get y squared equals 9. And what's the opposite of a square? Square root. And you get y equals 3. So that's great, because now we have the ability to say, they can change this y to 3, or put it in brackets here, or y equals 3. Now we have the ability to say what all the sine, cosine, and tan is. Sine of theta is going to be, we're referring here from this related acute angle. It's still for theta, but we're in this triangle. Sine of theta is opposite, negative 3 over 5. Cos of theta we were already given in the question, but you can check. Cos of theta is adjacent over hypotenuse. And the tan of theta, that's opposite, which in this case is 3, over adjacent, which is negative 4. And by the way, you can check, if you took the negative out, if you didn't use negative 4 here because it was a triangle, make sure you check in this quadrant, quadrant 2, the cast rule tells you that sine should be positive. Egads, and look, we had a negative here, that was a typo by me. That's why you check. Even if you use the negatives, make sure to check. We have sine is the right number, 3 over 4, but this was an equal sign, not a negative. Should be sine of 3 over 5, because sine's positive in this quadrant, cosine is negative in this quadrant, tan is negative in this quadrant. Okay, good to go. Now let's solve for the sine of 2 theta. Start with that one, because that one was first. Let's put a little line here. Sine of 2 theta. Let's pull out our formula sheet. Sine of 2 theta. Sine of 2 theta. Okay, so 2a is 2 sine cos of the same thing. So that's the same as 2 times the sine of theta times the cos of theta. I got that just from this formula right here on the formula sheet, which you'll get. So that's 2 times sine theta, 3/5, times cos theta, negative 4/5. When you're multiplying fractions, just top times top, and this you can think of this 2 as 2 over 1. So it's just top times top times top. 2 times 3 is 6, times 4 is negative 24, over 1 times 5 is 5, times 5 is 25. We got the exact value using a double angle formula. Let's do the next one. Cos of 2 theta. Now cos has a bunch of formulae. It doesn't matter which one you use. You'll have to believe me. You can try a different one on your own. You'll get the exact same answer whichever of these 3 you use. So which one do you want to use? It doesn't matter. I'll do the first one. Cos of 2 of something is 2 cosine squared of theta minus 1. So 2 times cosine squared. So we're going to square cosine, that's negative 4/5, and then take away 1. So we get 2 times square negative 4, you get 16. Square 5, you get 25. Minus 1. And now, when you're multiplying here, this 2, again, it's just 2 times the top, or think of this as 2 over 1, top times top, bottom times bottom. You get 32 over 25. Might as well right now change this -1 to the same denominator because I need to make sure I can subtract. And to subtract, I have to have common denominator. So 1 out of 25 is just 25 out of 25. 32 take away 25 is 7 out of 25. And I got it. Let's do the tan of 2 theta. I'm going to calculate that one as well. Tan of 2 theta, looking at your formula sheet, is 2 tan theta over 1 minus tan squared. Just looked at the formula sheet, that's how I got it. So 2 times tan theta, that's 2 times 3 over -4 over 1 minus the tan of theta squared. So on the top, this is like 2 over 1 again. 2 times 3 is 6 over -4. And on the bottom, you get 1 takeaway. And we're going to do 3 over -4 squared. So square the 3 and square the -4. You get 16. Now, some of you might be wondering, how come I don't reduce this 6 over -4? I'm not sure I'm going to need to yet. I'm going to wait and see. Leave this as 6 over -4. On the bottom, I got to do 1 minus 9 over 16, so I need common denominator. 1 is the same as 16 over 16. Take away 9 over 16. So on the top, I have 6 over -4, and on the bottom, I have 16 take away 9. You could use your calculator if you want, but that's 7 over 16. So I do need common denominator there. It wouldn't have been worth changing it to a 2, because I would have had to go back anyway. This negative on the bottom, though, is kind of annoying because it's hard to make common denominators when the bottom of the fraction is negative. I hope you know that when a fraction is negative on the bottom, it's the same as being negative on the top. 1 negative on the bottom is the same as 1 negative on the top, which means now I can just make this 4 out of 16. So how do you get from 4 to 16? You would times by 4, so times the top by 4. You get -24 out of 16. Oh, I don't even need to do common denominator here. What am I saying? Why would do common denominator? That's only useful if you're adding or subtracting. I'm dividing. I have a fraction divided by a fraction. So look at this. I have a faster way. In fact, and the other way was unnecessary. When you have a fraction divided by a fraction, it's the same as a fraction times its flip. That is, when dividing by a fraction, the first one stays the same. The second one, when you're dividing, it's the same as timesing by the flip. And now I can just reduce. Notice you can multiply first, then reduce, but you can also reduce right at this stage here. Notice that 4 is divisible by 4, leaving 1, and so is 16. So you can divide both by 4, and now multiply. You get -24 over 7. Whew, saved myself a lot of trouble. Didn't need common denominator because I was dividing by a fraction, which is just timesing by a flip. So I used double angle, formulae, and I solved.